Hi, this is Ronald Landhees from Vlinder Software, and today I will show you how to build the funky embeddable functional programming language. So the prerequisites for building Funky are Boost version 1.33.1 or later, which you can find at boost.org, Loki version 0.1.7 or later, which you can find at lokilib.sf.net, Funky version 1.3 or later. We'll be doing this with version 1.4, which we are about to release. A C++ compiler. I'll be using the GNU C++ compiler in this demo, but you can also use Microsoft Visual Studio or any other standards compliant C++ compiler. I'll be using Cygwin in this demo, and I've already built Loki, and if you need to do that, you'll need GNU Make and the C++ compiler. And we'll also be using Boost Jam, and we'll be building that, and to build that you need a C compiler, and I'll be using the GNU C compiler from the GNU compiler collection. So if we take a look at what's at the root of the source distribution, you'll find basically the same thing that you'd find if you downloaded the 1.3 version. You have the Jam root here. You have the Boost build, which is also part of the Boost Jam build system. The Bootstrap script probably won't be there anymore once we release the 1.4. You have the different demos of which we've already recorded, except for this one and the few ones that we haven't recorded yet. The source directory, which because we have a library to compile, is called lib. License, the unit tests, and the project files. Now, under the project files, we find the Boost build system, the project files for Doxygen to generate documentation, and MSVC8, which are the solution and project files for Microsoft Visual Studio 8, which is 2005. So we'll go into Boost, and there we find the Jam sources, and we find the files necessary for the Boost Jam build system. So we'll start by building Jam. Which is really very easy. You just do build. Jam is a build system that is a bit like GNU Make in that it tracks its dependencies and everything. But because it knows things about the environment it's in, such as how to invoke the compiler and the linker and that kind of thing, those are things we don't need to put in our Jam files, which is why we chose Boost Jam for for Funky, and we'll be using it for several other Vlinder software projects as well. And so building it generated an executable, which we will be copying into our path. There it is. So if we go back to the project root there, we can now run bjam. Running bjam like this won't work, and I'll show you why it won't work. As you can see, there are several errors, and all of the errors are actually basically the same. And that is, it can't find Boost. Boost, Spirit, no such file directory. It's the same error everywhere. Now, the reason for that is that Boost is usually installed in, well, the header files for Boost are usually installed in a directory that is named for the version of Boost we are using. So we need to include that in the search path for the C++ compiler. Okay, if we list the content of that directory, we find the Boost directory that the compiler was looking for. So in order to do that, we need to pass the necessary flags to the compiler through bjam. So we tell it that the flags for the C++ compiler are to include the directory in its include path. If we do this, it will compile without problem. Now, you will also notice that there are going to be a lot of compiler warnings. This is normal and it's not a reason to worry. The warning is the same at each instance. It's the variable might be used uninitialized in this function, and it's always at the same place. It's always in stl uninitialized.h. The reason for this is because the GNU C compiler, C++ compiler, generates a lot of warnings, and we turn them all on. And well, this is basically a warning in the STL that comes with the compiler itself. As we don't change the STL to be able to get rid of this warning, because we'd have to change it everywhere, we basically don't consider this a problem. There are no warnings in the code, in the C++ code for Funky itself, nor are there any errors, of course. Now, this takes a minute or two, maybe 3. Of course, this will compile all dialects because we're using the commercial version of Funky here. In the open source version, only Funky and Groovy would be compiled. And I should perhaps also note that there are 2 versions of Funky being compiled, one statically linked and one dynamically linked. So, if we take another look here, we find the build directory, and if we look in there, we find the static library here, and the dynamic one here, with the import library here. So that's all there is to building. If you want to know which files you need, if you want to install, in the lib directory you'll find all the sources. The header files are all named something.h, and the ones you don't need are all in the private directory. So if you want to install the sources somewhere where you can use them in another project, like we would if we well, when we distribute the binary version of Funky for the commercial version, you have all the .h files except the ones in private. And that's all there is to it. Thank you.